Hello everybody. In this episode, I'll be discussing with you one of the important aspect of electron microscopy is called transmission electron microscopy. It is not easy and it is not very easy to get the microscope even. Then it comes the operation part of it. Why? Because it requires a complicated optics, a complicated aberrations corrections, a complicated understanding. In the transmission electron microscope, unlike a scanning electron microscope, you need to understand online about the structures, about the features, and about the chemical informations together. So it is very important to understand is the concept, the theory part of it, as well as how to operate it, how to get the image information. All those will be discussed in the subsequent episode. So I'll be in general talking how this transmission electron microscope basically it operates. So basically, as you know, that most important part is sample preparation for transmission electron microscope. It only takes a 3 mm circular disc sample, or in the form of powder you can disperse them in a 3 mm carbon grade. So you need to have so many different types of instruments to make your sample to this dimension 3 mm. Just try to mention you again, it is 3 mm in diameter, small disc. Right from a material from sheep suppose, or from a bar, or from an aeroplane, you have to take a small amount of it. It is exactly like a small drop of blood from you can examine and tell details about you. Similarly, a small amount of material can tell all details up to atomic level in the TEM. In the transmission electron microscope, basically once the beam passes through, as you can see in the image, it happens that there are two types of information. One is the direct beam and it is called diffracted beam. A diffraction is a phenomena where from any one point the beam gets diverted and at a particular angle called Bragg's angle. Bragg angle is and the Bragg equation is very important, is well famous in the world of physics and science. As you know that father and son, both of them, they worked in University of Leeds in UK and they got the Nobel Prize to discover a very big understanding that from atoms, the electrons or any ions or any rays get deflected from each atoms and they coherently form intensity peaks. So that is called Bragg's law, which is explained here, and that gives us very important concept of diffraction and in subsequently giving information over the crystal structure. As you know, crystal structure is the building block of any material. If you understand that, we can modify that. As an engineer, we try to understand the crystal structure of that and then we engineer that to our desired property, which is possible using transmission electron microscope. So there are two modes. One is called direct beam, is called bright field, and is called diffracted beam, is called dark field, and you also get the selected area diffraction. That is seen, can be seen like this, what you have seen in the picture, that a series of spots in a symmetric pattern is seen. This is exactly, each dot is a set of plane for the crystal structure which you have available in your material. So each dot, so you get number of crystal planes, so you can understand how the material is formed, and you can magnify up to what level? Up to 5 lakhs, 6 lakhs, 7 lakhs, 8 lakhs, up to 10 lakhs you can magnify in the material with the resolution intact. This resolution is done by correcting the aberrations, the error in the electron path. So this all together is called transmission electron microscope. Along with that, what you can do an online analysis. You can find out the X-rays coming out from the material and you can put a EDS detector online, and simultaneously, apart from crystallographic information, you can also find out analytical information. So together is called analytical electron microscope sometimes along with the TEM. This is general definition and understanding of TEM. We'll be discussing details about how the TEMs can be used, what mode to be used, what are the different types of applications can we have, and how to understand your samples while doing analysis in the TEM. The other part of the TEM is called, the other important area is high resolution transmission electron microscope. As you know that beyond, if you want to go beyond 6-7 lakhs of the magnification, then you need to compromise its angular tilt. So if you compromise the tilt, of the sample, that means how to tilt it, because the information is of the crystals information, then you can go to high resolution mode. What we do basically in the diffraction, we take number of planes together and put an aperture to only allow those particular beam to pass through, and then to image those particular diffracted beam to form the image is called high resolution images. What happens, it starts from 10 lakhs and above. If you magnification I'm just talking of, this magnified image is called high resolution images, will be like as shown here, like fine fringes, fine hair like fringes. These fringes are same as your fingerprint. In your fingerprint you have circular rings, and all of them are different all over the world. Similarly, in these fringes are different for all material so far discovered in the world. That is, the fringes are separated by a small d. It is called interplanar spacing. This interplanar spacing, that is one atomic plane to another atomic plane, this d value is unique for different material. You take titanium, you take aluminum, you take titanium, aluminum, all of them interplanar spacing is different, and from each interplanar we get one line. That means you are able to identify which is that material directly from looking at these fringes, what is seen here. So these images are called high resolution images, and if you go for magnifying, you can start seeing the dumbbell shape of silicon. The silicon, if you want to magnify, you can start seeing them. The silicon doesn't stay, if you start magnifying, you will start seeing orbitals. So these orbitals basically where the electrons, as you know, the Pauli exclusive principle, electron doesn't stay at one place, neither you can find the position and the velocity together at one time. So there is a space where the electrons keeps on moving and atoms keeps on, so you keep on to image the electrons and the atoms together. It is called orbital, which is possible using high resolution mode of the microscope. So this high resolution transmission electron microscope can give you image of the orbitals of the atoms what you studied in your school days. Directly you can see them. That's why sometimes I keep on saying we like to follow how the seeing is believing. So once you are able to see them, you can see how they are placed, which element, how the structure, like suppose there is a cube, which corners are like occupied by which material, center of the cube, which material occupied, you can directly identify and you can understand the crystal structure. So this understanding crystal structure and the information was to get together is called high resolution transmission electron microscope. Apart from that, we can also find out the analysis, like there are various methods like alchemy is there. There are called convergent beam electron diffraction. These things will be details, analysis will be done, and the discussion will be done in the subsequent episode. I like to tell you that in this episode, whatever I have discussed and what is there in the next episode is very interesting. The advanced transmission electron microscopy, what it comes in the next episode, I'll be discussing. Like one of the things is precision electron diffraction, which is a new technique. The other one is in situ transmission electron microscopy. So these important topics I'll be discussing in the next episode. See you.